Hey there, everybody. Welcome back. Let's take a look at another problem in our 12.4 for Calculus 3. These are more examples of the unit, tangent, normal, and binormal vectors. Let's just jump right into it. The example we're going to do here is in the R of t is in 2 space, but to find the binormal, we're going to need 3 space eventually. But we're going to do it, we're finding it at t equals 1. So we can bypass a lot of work, which we will do. I will go back and show the work for the general form afterwards for those of you that want to see it. I think it's worth showing. We have R of t is 1/7 t to the 7th and comma t. So R prime is t to the 6th power comma 1. The magnitude is the square root of t squared plus t to the 12th power plus 1. So our tangent vector is t to the 6th power over t to the 12th plus 1, the square root, and then 1 over the square root of t to the 12th plus 1. I wrote it there, and I also wrote it in this form right here, where I moved the square root to the top as a power to the -1/2. I find it easier to do the product rule using this rather than the quotient rule. So I'm doing the product rule here. So I will do just focusing on the x component right now. Take the derivative of the first component, 6. I'll take the derivative of this. So we've got 6t to the 5th, and the second component stays the same. Then the first component stays the same, t to the 6th. We take the derivative of the square root of t to the 12th plus 1 with the -1/2. -1/2 comes down, we lower by a power -3/2, and then multiply by chain rule. The derivative of the inside is 12t to the 11th. When we do the y value, we have basically everything, that last part of this minus the t to the 6th. -1/2, the t to the 12th plus 1 to the -3/2, and 12t to the 11th. Then I rewrite it where I put it in the regular form. I just move the anything with a negative exponent down to the denominator. Here it's to the 1/2, and these are to the 3/2. So I can multiply this first piece right here, 6 times t to the 5th over the square root of t to the 12th plus 1. I can multiply this one by t to the 12th plus 1 on top and bottom, and then I will have a common denominator of t to the 12th plus 1 to the 3/2. And so I do that here, just I show it there. I distribute, and you will see we've got 6t to the 5th times t to the 12th is 6t to the 17th. And we're subtracting a 6t to the 17th, which is what we get when we clean up this part. Okay. So those components go away, and I'm just left with 6t to the 5th over that quantity to the 3/2, and the y component is -6t to the 11th over that same y component. That's my t prime of t. And that's where I'm stopping, okay? Because to do the next part, if we only want to look at a particular time, and what we want to look at here is t equals 1, we don't need to do the rest. So let's take a look at that real quick. I actually rewound a little bit. I went back up to here and plugged it in here. I found t prime of 1. I plug it in. You get a lot of algebra stuff going on. So 6, and then I've got the plugging in the 1. T is 1, so 6 times t to the 5th. 6 times 1 is 6. And then t to the 12th is 1. 1 plus 1 is 2. I've got 1 over square root of 2. That's that component right there. And then I've got plus a minus. So the minus is there. T to the 6th is 1. I've got the -1/2 there. T to the 12th is 1. So 1 plus 1 is 2. This is 2 to the 3/2 in the denominator. And then we have 12 times 1 to the 11th is just 1, so 12. That's my x component. Something similar with the y component. Basically, this is the same thing on the y component. Because the t to the 6 is just 1. So we get t prime evaluated at 1. When you clean this all up, you get 6 over root 2 minus 6 over 2 root 2. You could get a common denominator by multiplying this by 2 over 2. This becomes 12 on top. So 12 minus 6 is 6. 6 over 2 root 2 is going to be simplified at 3 root 2 over 2. Because we multiply the top and bottom by root 2 over 2 to rationalize. We do the same thing here, multiply the top by bottom by root 2 over 2 to rationalize. This part reduces to 3. I've got negative 3 root 2 over 2. So that's my x and y component. To find n1, I divide this by its magnitude. So the magnitude of that is done here. This is 3 root 2 squared over 2 squared, and it's twice. So the 3 squared is 9. The square root of 2 squared is 2, so 9 times 2 is 18. That's why I have 18 on top. And then the 2 squared on bottom is 4. So 18 over 4, 18 over 4. Add that up, I get 36 over 4, which is 9. So the square root of 9 is just 3. I'm dividing the top by that 3. It cancels with that 3 right there. And we're just left with root 2 over 2 and negative root 2 over 2. Okay, so I've got my n1. My t1. T is right here. If I just plug in 1, I've got 1 over root 2 and 1 over root 2. Okay, so that's how I got those two. Then we find b using those values. We don't do the general form. And you work that out, and you are going to get 0, 0, negative 1 for the binomial vector evaluated at t equals 1. Remember, that's what we're working on here. Okay. You can show these are orthogonal. I put them all three together, so they're all together. You can show they're orthogonal. Recall me saying that r prime, we can't do n of t equals r double prime of t over magnitude of r double prime of t. It doesn't work like that. It only works with n of s. We can take a look at that here. The first derivative, r of t, was t to the 6th and 1. So r double prime is 6t to the 5th and 0. 6t to the 5th and 0. So the magnitude of r double prime is 6t to the 5th. It's the only component. When I divide by that, I get 1, 0 or 1, 0, 0. But n of t is, that's not what we get for n of t, and I'll show you that right now. Let's get n of t doing the general form. This says we get 1, 0, 0, and we don't. So we left off with working on t prime. We got t prime looking like this in the general form. You can rewind it and watch that section again. We got to that. We need to find n by dividing by the magnitude of this. This is a pain in the ass, right? I don't know that this vector is any easier trying to shift to arc length either. We're going to have s to the 12th plus 1 in the square root. That's not that friendly. I don't like that. Let's just figure out what the magnitude is. Since they're the same on bottom, I could just square the bottom and put it together as one fraction. And the top squared, 6t to the 5th squared and negative 6t to the 11th squared, gets me 36t to the 10th plus 36t to the 22nd. The bottom is t to the 12th plus 1 cubed. We still got a square root. So the numerator has a common value, 36t to the 10th. And when we factor that out and take the square root of it, we get 6t to the 5th on the outside. So we have that on the outside. That leaves behind t to the 12th plus 1 on top, t to the 12th plus 1 cubed on bottom. They're the same thing. We can cancel it out, reduces to t to the 12th plus 1 squared on bottom, which is convenient. We take the square root, we get that. So that's the magnitude of t prime. When I divide t prime by its magnitude, here I wrote it as multiplying by it rather than the reciprocal rather than dividing by the magnitude. Divide by or multiply by the reciprocal. The reciprocal of this is t to the 12th plus 1 over 6t to the 5th. So I multiply that in. Some good stuff happens with the first component, right? This cancels out. This gets down to just the square root. The second one, the 6's cancel out. T to the 11th divided by t to the 5th is t to the 6th. We do have a negative sign still. And we still have that same reduction where the bottom is square root of t to the 12th plus 1. So we have t up here. That's a 6th power. I have n right here. I can show that the dot product equals 0 for all t. Just multiplying those two together. We get t to the 6 times 1 is t to the 6 minus 1 times t to the 6. So t to the 6 minus t to the 6 is 0 on top. Multiplying the, doesn't matter what we have on bottom, the top is 0. This is 0 for all t. I did not do the binomial vector, but notice my n of t here does not match the 6t to the 5th that we have right here. So r double prime divided by its magnitude does not equal n for all t. The last problem it just did in general form. I didn't do the binomial vector. If you want to work on doing that, maybe we could do that as a class exercise. We'll discuss it then. But it's taking this vector, and this vector, and crossing them by adding a third component. The third component would be 0. Okay. So this is algebra intensive, isn't it? There is a lot of algebra going on here. You need to take your time and be patient. Okay. I know you're gonna get frustrated. I know you will, but that's how the cookie crumbles in this class. Peace.